Okay, guys, so no vocab today. Go ahead, grab your books and a piece of paper. Flip your book open to page 588. On your paper, of course, first, last name, date, period, assignment number, book page, the regular things. Okay, what we're going to do is we're going to pick up where we left off last lesson. And if you remember, right, last lesson was a volume of prisms. And if you remember right, a prism is a three-dimensional figure where the two bases are congruent, meaning they're basically twins, the same size, the same shape. These today, you're going to see just pretty much review an extension of last week, except we're going to have not rectangular prisms, we're not going to have triangular prisms. We are going to have, you can think of them as circular prisms. We're going to have cylinders. We're going to find the volume of cylinders, and just a little reminder, right? We're finding out basically how many cubic units can fit underneath, or inside, of the cylinder. All right, so with that said, you should already be on page 588. Let's start by looking at problem number 2. Problem number 2. Okay, problem number 2, if you take a look at the directions, it says find the volume of each cylinder round to the nearest tenth. So you just see cylinders all up and down that page. However, number 2, it doesn't have a cylinder. It actually just has a description of the cylinder. So it says the diameter of the base says is 33.2 millimeters. And the height is 60 millimeters. So you could go ahead and start over here. We can go ahead, I'll call this step star. And that is just, it's probably best for many of us to draw a diagram of a cylinder. It could just be a basic cylinder. The way you draw a basic cylinder, if you're looking at it kind of from the side, maybe a top angle of the side, you want to draw kind of something that looks kind of like that. Kind of a long skinny oval. Then from each end of those ovals come straight down. And then to draw the bottom of the base to make it look accurate, don't draw a straight line. Draw a line that's try to get it identical to this half of the circle, or I should say that half of the oval in this case. So to make it look the best you can. All right, so not the best looking cylinder, but you get the idea. Now, on a diagram, it says the diameter of the base is 33.2. So remember, the bases are the circles. That's what makes them cylinders. So it says the diameter, remember, from one side of the circle to the other. Draw a little arrow here where I can fit in easily 33 2/10 millimeters. It also says the height is 60 millimeters. So it means from here all the way down here is 60 millimeters. Okay, so from here, right, you're going to see the exact same steps that you saw the other day. Step 1 is, let's go ahead and draw, or let's write the volume. We can use the volume of a prism, the formula. So remember, volume is equal to the area of the base, which is a capital B, times the third dimension, which basically they use as h for height. So step 2 is in this particular case, the area of the base. We're going to go ahead and put the formula for the base here. Well, the base being a circle today, all of them are going to be pi r squared if you're going to deal with a circle. Bring down my third dimension here, my height. The third step is we're going to plug in numbers for just to find the area of the base. So in this case, pi is 3.14. If you have your pi key, you can use that. Just understand, of course, it's going to create a little bit bigger answer. The radius in this case, squared, right? Well, the radius is not that. Remember, that's a diameter. Be careful with that today. Okay, so we have 33 2/10 divided by 2. We're splitting it in half to find the radius. It's 16 6/10, 16.6. All right, so here we go. I'll bring down the h just where I don't forget. I'm going to focus in on the area first here. 16.6 squared. I have 16 6/10 in here. I could multiply by 16.6, or if you have a square button, you could do that as well. and I have 275 and 56 hundredths. So 275 and 56 hundredths. And then now I'm going to multiply it with pi. So that times 3.14 equals, and I get 865 and 2,584 ten-thousandths. So then I'm going to turn around, right? That's the area of our circle. Now, you might be tempted to round it right now. Do not round. All right? So all we did is we plugged the numbers in and solved. Now, step 4 is actually, let's multiply it by the third dimension, or in this case, the height. So it's 60 millimeters. So I'm going to multiply this with 60 times 60, and I get 51,915 and 504 thousandths. Now, we'll call this also a step star. A little reminder is make sure you round. Rereading the directions, it says round to the nearest tenth. Remember, the tenth is to the right of the decimal. So I look here, 0 makes the 5 stay the same. So what we have is we have 51,915.5. And then, of course, like we had the other day, step 5 is put your units on. So we have cubic, don't forget cubic, right? Cubic millimeters. Okay. All right, so here we go. The one I want you guys to try is problem number 10. Problem number 10. All right. I'll go ahead and give you guys a couple of minutes. Go. Okay. All right, 30 seconds. Go ahead and turn to your neighbor and share. Go. All right. So here we go. Number 10. Number 10 says the diameter is 5 yards, height is 11 yards. So have a cylinder. Diameter is 5 yards, and the height, it says, is 11 yards. So here we go. We have just following through the steps. Area of the base times the height. The base obviously is a circle, so pi r squared times the third dimension, or the height. In this case, pi 3.14. The radius is not 5, it's half of 5, which is 2.5 times the height. 2.5 or 2.5, 2 5/10 squared is 6 25/100. I'm going to multiply that with 3.14 equals, bring down h by the way, that part equals 19 625 thousandths. Now I'm going to plug in the height, our last dimension here. So this is the area of the circle. Remember the other day, it's kind of like moving the camera down. We're seeing how many levels, right? It is, so it's 11 yards in height in this cylinder. So I multiply that by 11, and I end up with 215 875 thousandths. And double checking, but yes, it is rounded to the nearest tenth as well. So there's the tenths. The 7 makes the 8 rise up, and so we have 215 and 9/10. And double checking, the units, of course, is yards or square. I'm sorry, cubic. Be careful of that. Cubic yards. Okay. So here we go. Next type of problem. All right, on page 588, let's look at problem number 3. Okay, problem number 3, it actually shows us a picture of this cylinder, and the cylinder just kind of looking at it just like that, and it gives you a diameter here of 6 inches. And this shows h for height. But if you take a look above it, it tells you the volume. And if you remember right, this is kind of like the one problem we did the other day on our last lesson. So if you're using the formula properly, you should be okay. So here we go. We're going to go ahead and actually, everyone, we're going to follow the same exact directions. It's just that we're not going to be simplifying one of the sides. We're going to be solving an equation at the end. So I'm going to go ahead, since I'm going on this side, I'm going to use blue. You can see the difference in the two problems. So here we go. Volume equals the area of the base times the height. I go ahead, and this is a cylinder again, right? Pi r squared times height is equal to the volume. Then once I do step 3, which is I'm plugging in the numbers, I plug in 283 on this side of the equal sign. Pi, of course, is always pi, 3.14. The radius in this case is not 6, but it is 3. And don't forget, it's squared, times h. And h, of course, is what they're asking for. So here we go. I'm going to go ahead, I'm going to simplify this part right here. So this is 3 squared. 3 times 3 is 9. Rewrite your problem. Okay, I'm trying not to be lazy here. So all that times h. I'm now going to multiply 3.14 times 9. I get 28.26, 28 26/100 times h equals 283. And I'm going to go ahead and a one-step equation. Here's our h. I want to isolate it, right? Get it by itself, so I do the inverse. Multiplied with 28.26, I'm going to divide by 28.26. There and here. So that cancels. I have h equals, and now I'm going to use my calculator. 283 divided by 28.26 equals, and I get 10.014, and it keeps going. So what I'm going to do is I'm going to double check and see what the directions are on the rounding. It says round to the nearest tenth. Here's a tenth. The 1 stays the same. And ladies and gentlemen, our height is 10. And don't forget, of course, the units, inches. And like we said the other day, be careful. This is only the height. It's not the volume. So we're only talking about the length of that one side. It's just 10 inches. It is not inches cubed, cubic inches. Just 10 inches. All right. So the one I want you to try out very much like that is problem number 12. Problem number 12. All right. I'll give you guys a couple of minutes. Go. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go. All right. Okay, so here we go. We have I'm going to go ahead, just like I did here. Volume is the area of the base times the height, which means a cylinder is pi r squared times the height. I'm going to go ahead, start plugging numbers in. So the volume is right there. It's 41 5/10 equals pi is 3.14. The radius, be careful, don't split that in half. They actually give us the radius. It's 2. So 2 squared. And then times h. So when I simplify this side here, 2 squared is 4. And that's times 3.14. So 3.14 times 4, 3.14 times 4 equals 12 and 56 hundredths. So that's 12 and 56 hundredths. That's area of our circle. I'm going to multiply it with the height, and it's going to equal 41 5/10. So again, it's just a one-step equation. There's our variable, so isolating it, I do the opposite. The inverse, I divide by 12 56/100. Do the same thing on the other side. Those cancel. We end up the height being 41 5/10 divided by 12 56/100. And I get a long one here, 3 304. And again, we're going to round. So if I take a look, round to the nearest tenth again, 0 makes the 3 stay the same. So the height is 3 3/10, and it was in yards. So don't put squared, right? It's 3 3/10 yards, and that is your height. Okay? All right, let's take a look at one more type of problem. So here we go. Let's take a look at, on page 588, problem number 5. So if you take a look, it says an oak peg, like the one shown at the right, was used in a toy truck. Find the volume of the peg, round to the nearest tenth. So what we have is I'm going to draw it a little differently. Oh, I don't think you've ever drawn a peg like this. So here we go. It's the top here. And I'm going to draw it from a different angle there. So we have that peg, and it shows from here to here is 4 centimeters. And then it shows that right here, from here to here, is 1 centimeter. Shows from there to there is 3 centimeters. And from here to here is 2 centimeters. So this is called a composite figure. You have 2 cylinders. Here's what we're going to do. We're going to find the volume of one. We're going to find the volume of the other. And we're going to add them together. So here we go. We're going to do exactly that. We'll go ahead and write steps on this. Step 1 is find the volume of the first one. I'll just put volume number 1. So let's go ahead and just do the top one. Volume of the area of the base times the height. So volume, the area of the base is pi r squared times the height. So remember, be careful. We're not looking here. We're only looking at this cylinder up here. So pi r squared, pi is 3.14. The radius is not 4. That's the diameter. It's 2. So 2 squared times the height, which we'll keep as that for right now. The area of our circle, 3.14 times 4 equals 12 56/100. Now I bring down the height, which is just 1. Nice. That's very easy, right? 12 56/100. Now I'm not going to do any rounding right now. All I'm going to do is say, okay, that's the volume of the first one. Okay, now comes the volume of the second. Do it all over again, but now we're talking about this bottom longer part of the cylinder there, or longer cylinder. So here we go. Volume equals area of the base, which is pi r squared times the height. Pi is 3.14. The radius is not 2, right? It's 1. So 1 squared times the height. So 1 squared is 1, and 3.14 times 1 is 3.14. Now to find the volume, right, we have to multiply it with that, how many layers, like we could say. And in this case, it's 3 centimeters. That's our height. So the volume of that one is 3 1400 times 3 equals 9 4200. Okay, that's the volume of the bottom section. And now, sorry, I guess we should have labeled that. That was the second step. Find the volume of the second cylinder. And then step 3 is what we were talking about. You're just going to take the 2 volumes and add them up. 12 5600 added with 9 4200 I don't even have to put this in a calculator, right? 8, 9, bring the decimal down, 11, 21 and 98 hundredths. Round to the nearest tenth, which is here. 8 makes the 9 go up to a 10, right? And what does that do? Creates that being a 22.0. Put your units on. We can call that step star or even step 4. Don't forget your units. Our units are in centimeters, and we're talking about volume this time, cubic centimeters. Okay. All right. Volume of a cylinder.